So we're live. Thank you to everyone who is coming by the live stream broadcast today. The reason why we wanted to do this a couple years ago, we actually had a similar event. By the way, I'm Joe Bassett. I'm the president of Dawn Equipment Company. Should probably introduce myself. A couple years ago, we had started introducing products with the live stream, and we were talking about actually one of the first products we introduced was the X-Sense device. And today what we're going to show you guys is what's really the evolution. So what we're going to do is I'm just going to tour you around some of the hardware, some of our new down pressure control hardware, and then what I'm actually going to do is I'm just going to highlight some key points with a quick PowerPoint, and then actually ask for the feedback of the audience. Okay. So let's start. Let's start with the actuator over here. So you've seen on our social media streams for a while that we have a new actuator design coming out, which is the Reflex digital down pressure system. Okay. So the Reflex digital down pressure control system, it's called digital because basically instead of using proportional control, like most of the products in the market where you're basically, you have some valve and you're altering a coil current in a valve in response to what the necessary down pressure is. With the digital down pressure system, what we're doing is we have these two very small efficient valves that we're pulsing up and down. We're pulsing them on, pulsing them off to either increase or decrease pressure in the system. And we have a pressure sensor that actually is directly measuring the pressure, right? So the change that you see here, which is really the ultimate evolution of the Reflex system, is the fact that we now have multiple channels involved, okay? So originally when we just had down pressure, we had two valves. What we've come to realize we can do with this system, which really provides unbelievable precise control over the down pressure, is that we can extend this system to control effectively everything on the row unit. And so today what we're talking to you about is the first of that next generation of planter row unit control products that we're bringing to market. That product being the X-Sense ADC module, active depth control module. But we'll get there first. So one of the beautiful things about this design is that everything is coupled into one single unit, okay? We have the actuator design itself that produces the down pressure to the row unit in the middle. We have the manifold which contains the pressure sensors and the valves on one side. And we have the computer controller off on the other side. This manifold is supplied by two hoses, one pressure, one return. And from those two hoses, we're powering the row unit down pressure, we're powering the active depth control device, and we're powering a yet to be announced additional product. You guys can read between the lines on that one. Effectively taking every single thing that was a human adjustment, an operator adjustment, and making that a automatic adjustment, okay? This product is a big change in strategy for us because what we're going to do for the first time with this product is we're going to also be providing a handshake where we're going to openly supply the CAN message structure that controls the depth control system so that other third parties could control the depth based on what type of seed you're planting, based on soil maps, based on all sorts of different things, okay? Notice the controller, this beautiful controller is housed in an aluminum, and this has a heck of a lot of stuff in it, okay? You have the power and CAN that comes into each row here, the power and the CAN coming out of each row here. So you daisy chain in, daisy chain out. You have the fuse, you have the main valve connector, you have the X-Sense valve connector, and you have the auxiliary valve connector for the third control channel there. You have LEDs that indicate when a valve is on and off, and also the condition status of the controller. And you have the switches indicating which row it is. So let's start off. And the nice thing, it's a nice compact package. This device uses the same upper and lower mounting dimensions and mounting components that we use on the RFX system. Also, as you know, which uses the same ones as the Deere OEM's components, which are what these are. That's very convenient, so you can directly port this over. And when you look at this device right here, let's kind of go into detail about how this works. So the main point is that the active depth control device is the gauge wheel load sensor also, okay? So we're sensing the down pressure and we're adjusting the depth with one single device. And I'm gonna get to kind of how we got there a little bit later when I just run through a very quick PowerPoint. So what you have is this casting, okay? I have one here. So this cast piece fits over the row unit and it locks in to where the row unit shank casting has the depth adjustment. So it's actually rigidly located relative to the row unit. And it's bolted in place in two places, rigidly mounted. And it has this precisely machined slide right here, okay, on either side. And the guide can slide along these surfaces right here, okay? It's super high precision, just a couple thousandths of clearance right there. And attached to this guide, there's an inductive distance sensor, a non-contact sensor, okay? And that sensor is basically sensing how close it is to a metal target. And so there's a very precisely machined cam profile right here, so that as you change depth, it's basically changing the voltage output in that sensor. And it's doing that super precisely, okay? So right now, it looks like we're gonna be adjusting the depth in like 1/16 of an inch increments. Hopefully it's a little bit better, but we can get more into that in a little bit, okay? Here's a tiny little thermoplastic hose, which is supplying the pressure to this module, and then here's the pressure sensor, okay? And the pressure sensor, that's what's actually telling you what the down pressure is in the row unit, okay? So the fluid pressure inside the cylinder, so there's a little cylinder that pushes against a little follower here, and once it achieves the desired depth, both of the valves on the manifold close, and this basically becomes a closed system, okay? And so the pressure in this manifold becomes becomes an analogy to what the gauge wheel load is, okay? And this is a return spring that basically pushes it into a retracted position. It's a single acting design. And then this is a diagnostic coupler so that you can stick a gauge or a sensor or something else for a data acquisition device, okay? So the way that this works is, let's see here. The controller tells the system that it wants to be at a certain depth, okay? It either increases or decreases the pressure opening or closing the valve there to achieve until it's within the dead band of where it needs to be, okay? So what we have is we say, okay, I want to be at a 1-inch depth, and there's a programmable tolerance, which is like, you know, a 1/16 of an inch, like I was saying, is about where it's at. And when it's within there, it says, hey, I'm stopping, I close the valves. If for some reason during operation, the depth of the system falls outside of the target range, then it shifts modes and it returns it. So it's constantly modulating in order to make sure that it stays at the commanded depth, okay? And then you're simply either, when you're in automatic depth control mode, okay, basically what it does is it has two modes. So it momentarily shifts out of automatic down pressure control mode and while it's in automatic depth control mode, and and then it flip-flops back and forth. So it's not simultaneously in automatic down pressure control mode and active depth control mode, okay? So effectively what we have here, and I know people are at work and I don't want to keep people for too long, is a super high resolution down pressure control system and a super high resolution depth control system. Plus the ability to control either the residue manager or we're going to be introducing the system will also have a closing wheel control system, which is the last channel that will be introduced, we're hoping, for Louisville, the National Farm Machinery Show. And every single function of the row unit will be controlled by one single element here. We don't have to worry about where to mount it here. Or, increasingly a lot of the mounting points around the row unit are there's just other products or different things that are mounted to it. It's like everything is in one piece. Everything is in one concise place that we like it. This design right here, you know what, let's go over to the PowerPoint quick here. Because I know a lot of people will kind of be asking the question, why, right? Why is active depth control, why does it matter, Don? Why is that really possible? Is that really relevant? And so the main thing I want to talk to you about really quickly is how do we get here? So as you know, like we've talked about a bunch of different times, we have been looking around for an alternative to the strain gauge type gauge wheel sensors for several years now. And in fact, one of the very first times we ever did a live stream, we started talking about this device right here, okay? Here's the very first Xsense device where we said, hey, maybe we can take, instead of using a strain gauge, which we don't like, it's pretty commonly known why we don't like the strain gauge type sensors. They are very hard to get consistent calibration. They are very sensitive to temperature. They are fragile. They're expensive. There's a whole lot of different reasons. So we started working on the fluid pressure type sensor several years ago, and this was the very first one. Hold on. Hey, Marty. Hey, I'm doing a live stream right now. Can you Sorry about that. So this was a very first prototype. We had ball bearings right here, a big stack of washers, pretty terrible. And then we kind of moved that concept one step more to the another Xsense device. This one is for John Deere, where it was a little bit more evolved version of that. Here's another similar concept for Kinsey. And we basically had spent quite a lot of time developing the system, and we knew, like, hey, this is really the real deal in terms of the accuracy of the gauge load we're getting and the performance characteristics of it and the reliability over time. That's good, but we did several hundred hours of testing on this device and this device here this summer, and basically realized, okay, for this. First of all, these are things that sat inside the shank. We're like, those are a chore to install. Well, if I want to make one that fits both John Deere and Kinsey, I have to make two completely distinct devices. And then we also knew that we wanted to look at the total cost of the system and the expectation of longevity and the fact that we really want to get something to the point where we're getting, 1,000 hours out of it. And basically, all of these things came into focus around the idea of saying, hey, for the same cost as this or this, we could do the depth control basically as a mechanism for delivering a very high quality down pressure control and deliver you the depth control at sort of a freebie there, okay? Brief overview. I'm going to be really quick here. Ronnie, can you look back here? Okay, digital hydraulic control. IP69. Notice all of the sensors, all of the connectors, completely dust and waterproof. Okay? It's non-contact. The distant sensor is totally non-contact, which is the main thing. This thing is going to be covered in dirt It will be needing to be pressure washed, okay? Notice it's greasable too. It acts as a gauge wheel load sensor, replacing the strain gauge designs, controls depth in 1/16 inch increments. The depth control has tolerance, and so it basically does nothing unless it falls out of tolerance, then it adjusts. It allows the true seed depth data to be logged. So it's another channel of data that we can record and have as a check, okay? So rather than basically directly measuring the ground contact, you have, it's another channel we can kind of log. And again, we will basically be publishing an open CAN API to let other systems change depth. Whether it be based on, okay, you are getting a prescription that says I'm planting XYZ seed, and it's beans or corn, and I entered it into my monitor. The vision is that you will not walk back to your planter and do this 24 times. You'll plug that in, and your planter will know what it's planting, and it will just go to the right depth, or it will go to the depth that whoever makes the seed wants the seed to be planted at. Okay, compatibility, I covered that. Most deer with a cast shank. The beauty of this design is that we can make a very similar design that also fits Kinsey 3000 and 4000 series row units, because the shank design is effectively identical on those row units in that depth adjustment area. It's only going to be compatible with the reflex down pressure system, right? We're not going to be making these products to fit with any other types of devices. This is going to be a complete cohesive system. Reflex product tiers. Okay, now let's talk about the reflex product strategy, because the first reflex down pressure systems are going to be coming to market this year. Reflex Basic will be a down pressure only system and use the strain gauge load sensor, okay? This is going to be priced very similarly to where it kind of was with the RFX. Next tier is the Reflex ADC, which will be down pressure control with the fluid pressure gauge wheel sensor, and then you're going to be adding active depth control features from there. The third tier of the product is the Reflex ADC ACS, which takes the active down pressure and will add the active closing system, where we're going to have a future product announcement. So the idea is to kind of, and notice the beautiful thing is that when you upgrade these pieces, all of the computer processing that you need to do the additional systems is already built in. You're going to be connecting harnesses to it and then buying the hardware, but you're not replacing the controller every time you upgrade the system. That was a really key thing for us, was to have a good upgrade path. Okay, so now let's ask the main question, which is what everybody's thinking of: why would I ever want to do that? And we don't know everything, but basically the hypothesis is basically this thought experiment right here, okay? Let's think about soybeans, for instance, or other crops that are very sensitive to moisture. Could you produce more uniform emergence by changing depth based on soil moisture? Okay? So currently, the state of the art in planter thinking, and which correctly so, is I want to plant every seed at exactly the same depth, right? That's what gives you uniform emergence. Okay, and what we're doing here is we're kind of looking into the future and saying, what if once we achieve that level of precision where we can plant every seed at the same depth, would there be other opportunities where we could minutely or change the depth of the planter? Say, for instance, you're going across the field and you're down in Texas, and you're all of a sudden it's late in the season and it's dry, and you're not planting into moisture, and rather than just laying that seed in dry dirt where it's not going to emerge forever, your planter just knows that and it just moves you deeper based on your moisture. I actually think that's going to happen fairly soon, and I definitely think that this product long term should be driven by other things. And when I was talking about a change in our strategy at Dawn, that's really what I was talking about, is that this new planter automation integrated system is something that I think really deserves to be connected to other products on the market, deserves to be kind of like a Internet of Things device, where other companies that might make a sensor could handshake with our device that makes the actuator, or other companies that make the monitor that is interfacing with your seed prescription could interface with our device. And that we're really kind of seeing a need for this new open handshaking of different products. Okay, so there's hypothesis one. Okay, this right here, we're not agronomists, not even close are we agronomists, right? I live vicariously through farmers and basically make products based on what I hear from people that are professional farmers and agronomists. So I'm interested in feedback here. Like what gain do you think there is? And whether people think that there's really could be a market for such a product. Here's hypothesis two. One of the things every spring when I go out and plant with customers, we go out and we set the planter and we set the depth, and they're kind of like, oh, go 4 notches and 4 notches. And then we go out and we plant a little bit and dig some seed, and they're like, oh, it kind of looks, this way, and oh, we're kind of at 2 inches. And I was like, who decided that this depth was the perfect depth? Do we know that 2 inches or XYZ is the perfect depth? Like, why is one depth really the perfect depth? And then I kind of started thinking, would it be possible if you had the ability to optimize based on minute changes in depth? If you could precisely and automatically make very minute incremental changes in the depth that you're planting at. So basically what I'm envisioning is saying, okay, well, people plant corn around 2 inches or whatever. What if you could go out in the field and do test strips on depth? Okay, where you would do one strip at 1 3/4 inches, and then you do another 100 feet at 1 7/8 inches, then do another 100 feet at 2 inches, then do another 100 feet at 2 1/16, then do another 100 feet at, and then come by with the yield, with the combine, and see if there could actually be differences, right? Because the closing wheels go in the ground a certain amount. And so the closing wheel pressure is relevant to it, what the true seed depth is. Because I guess from a pure kind of thought experiment standpoint, I was thinking, well, it's not, the way that people choose their depth is not very data driven, right? It's kind of like what would be the tribal knowledge amongst farmers, right? Where there's like, it's a best practice where we plant this deep. Well, why? Maybe different corn or beans want to be slightly deeper. If you have the ability to control it very precisely, maybe you could be more data driven about seed depth. So that's the second thought experiment there. Okay. And that's really the feedback that I'm interested in. So the last thing is that we think we can do this at a cost target, which is comparable to some of the strain gauges, right? If you went and you bought a strain gauge part, you would spend $100 for some, you might spend $200 for other ones. We think using these really robust, low-cost automotive style kind of sensors, we can deliver this solution at a price point that makes this very reasonable and makes this something we can do. So that's pretty much it. Maybe give a zoom in a little bit on the design to kind of let them see how it mounts and so on and so forth. There's plastic nylon guides. It's not metal on metal contact here, by the way. So you actually have a wear component in there. So in order to do this effectively, we do have to make this device with very high tolerances. And luckily, at Dawn, one of the things we're good at, one of the things we're bad at is like, I don't know, effective marketing and sales and other things. And things that we're good at is making things that are very tightly toleranced for reasonable prices. So this kind of fits in our wheelhouse too. On the production devices, I do want to flip-flop the color scheme on this inductive sensor, right? So here, watch this. See if I can do it here. So the maximum range of this sensor is about 0.28 inches. Oh, here, let me.
They want to know.
What's that?
They can see it in action.
Oh yeah, here, let's just do that. wish I would have done that before I adjusted it. Here. Okay. I might have just screwed it up a little bit there.
You might want to mention the speed. They want to know what happens when you hit a mud hole.
When you hit a mud hole?
The speed of these valves is as fast as you can get a valve to go, about 6 milliseconds. So when you hit a mud hole, this guy is, rigid. Okay?
Yeah, so if this is not adjusting, this is a rigid system, right? This is like, you could stick a plug in here. It's a rigid system. The only time this moves is when you're making an adjustment, right? So when you... It moves faster in one direction than the other, but we don't really want it to move very fast.
Realistically, you'd never need it to move faster than that. As you're moving from one management zone to another, realistically, you're not going to need to move any faster than that.
Well, but see, that's one of the things that I also thought about, right? So the beautiful thing, if you were to do this in another way, you might take like an electric linear actuator or something like that, which would take a lot more power and be a lot slower acting. I think that if we imagine a future where you do have moisture sensors, you will need to have something which is relatively fast operating, right? Part of designs like this are actually theoretical, where we're imagining what the future's going to bring. And we don't want it to be, it needs to not take a long time, but it needs to be very stable and kind of, in a reasonable amount of time. Okay, so let's just move it in little increments here. You want to know one of the biggest problems? Well, maybe it's not a problem, maybe it's a feature. So none of the components, like inside of here, the existing factory handle and adjuster and equalizer need to be changed. This bolts on over the outside. So this is adjusting the same equalizer kind of mustache piece, that's the factory piece, and so it fits over the top of everything that's already there. It doesn't really change the performance of what's there in any way, and you don't have to be fishing around inside of there, to replace different components and so on and so forth. It's a super, just notice it's greasable. There's almost no play in here.
Calibration.
Yeah, so
They're asking about calibration.
Oh, okay. So there's a calibration system built into the software where you are going to go to the minimum travel and set that, and the maximum travel and set that, right? And so from the factory, when we would ship this, we would preset this distance at min and max with a feeler gauge, so that distance is set, which says this voltage is. But then when you put it onto your planter, well, in theory, most planters are relatively close, but your V openers might be a little bit worn out, or different row units might be slightly different from the other. So there will be the ability to calibrate. One of the things that I think the mistakes that we've made on our systems previously is giving too many calibrations and giving people too many variables to play with.
They're wanting to know about when closing wheel stuff is coming for Louisville.
Right. Notice there's two other empty spots right here. That's where our last channel is. Okay? That's where our last plug-in is here. So that'll be our big deal at Louisville. Partially I guess I'm personally envisioning a future where the row unit will be completely automatic. I was blogging about this a couple months ago about the intersection of technology and farm equipment and society, and I think that every single thing that you used to take your hand and do is going to be replaced by something computer controlled. Okay. Increasingly, I think that self-driving vehicles are going to become, it's definitely going to happen, and that a move towards greater automation, more and more data-centric driven decision-making in farming, and so on and so forth. And we're just connecting the dots and saying, all right, well, we know that uniform emergence is probably the single most important thing that you can do to affect your yield. So what other variables other than constant down pressure, constant things like that could impact uniform emergence? Something that is actually changing with respect to soil conditions or based on other maps is there. So our vision is that we will provide the most power efficient hardware, the best hardware, and then these products will in some way need to handshake with other precision farming products at some point in the future. So I think that pretty much covers it. This is actually fairly simple. There's very few pieces in this.
They want to know isobus versus...
I think isobus is dead. I think we need something new. I think we need to start with a new isobus. First of all, we have a bit of a problem in that, okay, so now we have, it used to be that you would just have one thing on a row unit. You might have the population that was had feedback over the bus, right? Well, now we have valves opening and closing in 6 milliseconds. We have high frequency down pressure. We have sensors. We're gonna have all these different channels on that. We could very easily have an automatic row cleaning setup at some point too. Okay. Well, all of a sudden there's way more bus data going on. So we've been kind of thinking about clocking this bus at a gigabaud. Okay, and keeping compatibility, long-term compatibility, I just feel like isobus is too far in the past. I think that personally what my dream would be if we could work, and this is when I go back to the new Dawn equipment, about a Dawn equipment which is more of a cooperative Dawn equipment than we've been in the past, and that we maybe get together and say, okay, maybe we're not going to have an international standard like isobus. An international standard like isobus, that's not going to move fast enough for us. We don't want to, that's just too slow. But we have a ad hoc standard which is agreed upon by different people, where we basically form an ad hoc standard that allows this component, these components to operate with other devices. Some of the devices that are CAN to internet devices that basically are portals from cloud data systems to the CAN bus on the tractor and the implement. Okay, I'd really like to have a standard with them. I would like to, yeah, I mean, clearly what we do well is hardware. What we do well is sensors. What we do well is actuators. What we don't do well is mapping. What we don't do well is, human interface devices. What we don't do well is that stuff, right? Okay, our wheelhouse is not the screen that you're looking at in the cab. We make these devices here in this factory with the machines you can be hearing while we're doing this. That's the core of what we do. Machining high precision things is part of the core values of what we do. We just happen to make high precision machine things that are farm equipment, and that's what we love to do. But, there definitely is a need to build out the data end of this product line a little bit. So we're going to sit down and kind of think about that, and maybe look around for some partnerships. So maybe there will be something coming on that front too. So I don't want to take any more of people's time. I really appreciate you. Anyone who is actually watching this broadcast, I am going to say thank you, and I appreciate you for being interested enough in what we do, interested enough in these very, idiosyncratic, kind of unusual pieces to take the time out of your day and to watch it. So thank you.